All right, let's have a look at the idea of the definite integral. This says if the integral of f of x with respect to x is equal to some function of x plus c, the constant of integration, then the definite integral of f of x between the limits x is equal to a and x is equal to b is given by the integral of f of x from a to b with respect to x is equal to some functions of f, and inside of a bracket, and the upper limit is b, the lower limit is a, and is equal to f of b minus f of a. All right. So the best thing actually is to just show it to you and try and explain it. Best thing to do is to show you. All right. Here are some results. Some results of integration. All right. You can actually um, record these in a notebook, and additionally, you should actually try and analyze them to see if they make sense to you. All right, record them and try to analyze them to see if they make sense to you. All right, here are some other results. Pause the video anytime and record it if you need to. All right, here's an example. Example 58. It says find the integral, the value of. All right, and we're going to integrate this function of x within the limits 0 to 1. All right, so the first thing we do, let us integrate. So this is a power integral, a straight power integral. If I integrate x squared, the power is going to increase by 1, and then I must divide by the new power. Same thing, I have 2x, the power increases by 1 from 1 to 2, divide by the new power 2. And if I integrate 1, I'm going to get x. All right. Now, because you're using limits or you're integrated within limits, you do not need to put the constant of integration. This is 0 and this is 1. All right. So first, I'm going to put in when x is equal to 1. So I'm going to have 1 cube over 3. These cancel. So plus 1 square plus 1 minus when x is 0. And when x is 0, everything over here is going to become, well, let's just put it for the time being, 0 cube over 3 plus 0 square plus 0. So as you can see, everything over the right hand side becomes 0. So my answer here is 1/3 plus 1 plus 1. So this is 2 and 1/3. All right. So the value of this integral is 2 and 1/3. Example 58. This says evaluate. All right, so let's integrate. Again, this is straight power integration. So our integration of the form ax is equal to n. When you integrate, you're going to increase the power by 1. So I'm going to get 4x to the power 4 divided by the new power, which is 4, minus 2x to the power 3 divided by the new power, which is 3. And this is within the limits 1 to 2. So this is going to become x to the 4th minus 2/3 x cubed, 1 to 2. So first, when x is 2, I'm going to get 2 to the 4th minus 2 over 3 times 2 cubed, minus when x is 1, I have 1 to the 4th minus 2 over 3 times 1 cubed. 2 to the 4th, I think, is 16. So this is 16 minus 2/3 of 8 minus 1 minus 2 over 3 times 1. Alright. Alright, to the right hand side, I'm going to have this is equal to, and I have 16 minus 16 over 3 minus that is what, 1 minus 2/3. This becomes 3. 1 to 3 is 3. 3 times 16, what is it, 48 minus 16, and this is minus 1/3. So I'm ending up with 22 minus 1 all over 3. The answer is 31 over 3. Example 60 says find the value of. Alright, so let's just write this in more useful format. This is from 1 to 4. The root of x is the same as saying x raised to the half power plus 3, bring the x up, x to the minus 2. And I'm integrating with respect to x. So now basically I'm doing the power integral. When you integrate, you're going to increase the power by 1. So this becomes x to the 3 over 2 divided by the new power, which is 3 over 2, plus 3. Increase the power by 1. You get x to the minus 1 divided by the new power, which is minus 1, within the limits from 1 to 4. This becomes 2/3 x to the 3 over 2 minus 1, minus, I have 3 at the top, and down by the bottom I have x. And this is from 1 to 4. So dividing by 3 over 2 is the same as multiplying by 2/3. Alright. X to the minus 1. 3x to the minus 1 is the same as saying 3 over x. Alright, first, when x is 4, I'm going to get 2/3 of 4 raised to the power 3 over 2 minus 3 over 4. Then minus, when x is 1, I have 2/3 times 1 to the 3 over 2 minus 3 over 1. So next I'm going to have this is equal to 2 over 3 times 2 square, because 4 is 2 square, times 3 over 2. The powers inside the bracket is multiplied by the power outside, minus 3 over 4, minus over here I have 2/3 minus 3. Alright, 1 raised to any power is 1. So 1 to the 3 over 2 is still 1. Alright, so now I have 2 over 3. And here this cancels that. So now I have 2 to the 3, which is 8, minus 3 over 4. And this is minus, let's say, 2 over 3 minus 3 over 1. So now I have 16 over 3 minus 3 over 4 minus 2 over 3 minus 9 over 3. 12. 4 times 16 would be what? 64 minus 3 threes would be 9, and then this would be minus minus 7 over 3. So this would become 55 over 12 minus 7, sorry, negative times a negative is a positive. That would be 7 over 3, which is the same as saying 28 over 12. So my final answer would be 83 over 12. All right. This says find the exact value of. All right. So let's integrate. If I differentiate cos, I'm going to get minus sine. So if I integrate sine, I'm going to get minus cos. So this is minus cosine x plus, if I integrate 4 with respect to x, I'm going to get 4x. And the limits is 0 to pi by 3. So first, when x is minus pi by 3, I have minus, and then I have cosine of pi by 3 plus 4 times pi by 3 minus the cosine of 0 plus 4 times 0. So pi by 3 is 60 and cosine of 60 is a half. So this is minus a half plus 4 pi by 3. And over here, the cosine of 0 is 1. So I have minus minus 1 minus minus 1. So now I have minus minus 1 is plus 1. So it's 1 minus a half plus 4 pi by 3. So this is a half plus 4 pi by 3. Example 62, it says find the integral from 0 to pi by 2 of 4 sine 6x sine 2x dx. All right, here I place an identity to sort of remind you how you're going to go about the answer. Essentially, I'm going to convert the product to a sum, or product to this to a difference. All right, so let's try and get the integral to look like the identity. So if I, let's say, separate 4 into minus 2 times minus 2, I'm going to have minus 2 times the integral from 0 to pi by 2 minus 2 sine 6x sine 2x dx. All right. Now, by separating it like this, by doing what I just did, I now get the what I'm integrating to look like the identity. So now I can say that this is equal to minus 2, the integral from 0 to pi by 2 of cosine 6x plus 2x, which would be cosine of 8x minus the cosine of 6x minus 2x, which would be 4x. And I'm integrating this with respect to x. So this is minus 2. Let's integrate. Differentiate sine, I get cos. If I integrate cos, I'm going to get back sine. So this is sine 8x divided by the differential of the inside function, which is 8, minus sine 4x divided by the differential of the inside function. The inside function is 4x. If I differentiate 4x, I'm going to get 4. So I divide by 4. And once you have limits, you do not need to put the power, you do not need to put the constant of integration. And this is from 0 to pi by 2. All right, let's multiply across by the by minus 2. All right, so in other words, let's apply distributive law. So I'm going to end up with minus sine 8x over 4. Negative times a negative is a positive, and I have sine 4x over 2. 0 to pi by 2. So this is minus. I'm going to have the sine of 8 times pi by 2 divided by 4 plus the sine of 4 times pi by 2 divided by 2. Minus, and then now when x is 0, minus sine 8 times 0 over 4 plus sine 4 times 0 over 2. This is going to come down to, so I'm going to have equal, and then I'm going to have minus sine of 4 pi minus sine 4 pi over 4 plus sine 2 pi over 2 minus the sine of 0 over 4 plus the sine again of 0 over 2. All right. The sine of 4 pi is the same as the sine of 0, which is 0. So what I'm seeing here, the entire thing is 0. It's going to be 0 plus 0 and 0. The entire thing is 0. The entire thing comes to 0. Because the sine of 4 pi is 0. 0 divided by 4 is still 0. Sine of 2 pi is 0. 0 divided by 2 is still 0. Sine of 0 is 0. So it's just 0. The value of the integral is 0. All right, example 63. All right, again, what I'm going to do is I'm going to manipulate the integral or the function that I'm integrating so that it looks like the identity. So I'm going to multiply and divide by 2. So I'm going to end up with I divide by 2 and I'm going to multiply by 2. 0 pi by 4, and I have 2 sine 2x cosine 2x. What did I do? I multiply and divide by 2. Alright, so now this becomes a half the integral from 0 to pi by 4 of, we're going to have sine 4x, and this is with respect to x. Now if I differentiate cos, I get minus sine. If I integrate sine, I'm going to get minus cos. So it's a half minus cosine 4x divided by the differential of the inside function, which is 4 from 0 to pi by 4. Alright, so this is going to be equal to a half. First, when x is equal to pi by 4, I'm going to get minus cos 4 times pi by 4 all over 4 minus cosine, when it's 0, 4 times 0 all over 4, and of course it is this entire thing that I'm multiplying by a half. So now I have a half, and I have the cosine of minus the cosine of pi. 4 is cancelled over 4 minus minus, which is plus the cosine of 0 over 4, and this becomes a half. The cosine of pi, which is 180, is minus 1, so minus minus is plus 1 over 4. The cosine of 0 is 1, so again this is 1 over 4. So this becomes a half times a quarter plus a quarter is a half, and a half times a half is 1/4. So the last example we're going to look at is example 64. Alright, let's write this as this is equal to the integral from 1 to 2 of 4 into 3x plus 2 all raised to the minus 2 power. Alright, let's get the 4 outside. We have 4, and this is the integral from 1 to 2 of 3x plus 2 to the minus 2 power. Now if I integrate this, I'm going to get 4. Then I'm going to have 3x plus 2. The power is going to increase by 1, so the power becomes minus 1. Divide by the new power, which is minus 1. And I also have to divide by the differential of the inside function, which is 3. So I have to divide by two things. I have to divide by the new power, and I have to divide by the differential of the inside function. So this becomes, let's get back the 4 on the inside. Let's say it's 4 and it's negative, and this down here becomes 3 into 3x plus 2 All right. All right, and that comes straight from the laws of indices. And this is 1 and this is 2. Substituting first, when x is 2, we get minus 4 over 3 into 3 times 2 plus 2 minus a minus 4. Substitute next when x is 1 over 3. Let's say 3 into 3 times 1 plus 2. So this becomes minus 4 over 3 times 8 minus minus, which is a plus 4 over 3 once 3 plus 2 is 5. So this is 3 times 5. All right. So I'm ending up with minus 4. Sorry. Let's cancel the 4. Minus 1 over 3 times 2 over 3 times 2 plus 4 over 3 times 5. All right, so it's 6 and 15. The LCM would be 2 times 3 times 5. The LCM is 30. All right, the LCM is 2 times 3 times 5. So this goes into this 5 times. It's minus 5 plus this into this goes 2 times. That's 8. So our answer comes out to be a positive 3 over 30, which is 1 over 10. All right.